Let's do that. Then we have this point there, right? Then we have that. Then we have this point here. That was A, that was B, this was point C, this was point D. Then, of course, we eliminated the other side of the diagram because we're using the right hand side. And what we're interested in is everything that's happening on this section. So here we have what? We have 2 kilonewtons. Then from there, of course, we had something like this, right? It's coming until here. Okay, so we have something like that. Is it like that? How's the member? I forgot it. Oh, it was Oh, yeah, yeah. Here. It's the same. So there's an angle here, there's an angle there. Okay, so we have that which will come here because it's a member, because this is G, right? That's A, B, C, D, E, then here there's F. Yeah. So from there, we said when we had made our cut, right? So our cut had gone through all these members. So we had, in this sense, we had also, since this is a member, right? So we had a member, and it's in this sense. Then in here we had this sense. So this was, we said this is, it can be G, G, it can be G, G, they're the same things. So N, G, D, and here it's N, G, F. G, F, then we said this is our angle at F. So it was theta F, which we had computed, and this is our angle theta D, which we had computed. And of course, we said this angle here, what's the value? 26 point what? Point one? 27?
How was it?
26.67. Okay, 67. That's the angle. Then we said this angle here is what? 56.31. Okay, degrees. So we have that information. Okay, so we said all this after the cut is not necessary for our solving, but the only thing that was necessary, of course, was understanding the geometry, because from there it was 3, and of course we had from this point here to there it was also 3, and the whole distance was what? 4.5, and what we had here was 1.5. So that was really essential to help us find the angles, because we said for finding the angles, always look for the closest right angled triangles that you can identify. It makes things much easier. Then we said since we have the angles, we know that this is our x positive, meaning in all the directions this is our y positive. It's the same that have planes here as our x positive, and this is also our y positive. It's the same that happens here. It's our y positive, that's our x at each and every joint. So once we have that, what is essential to do is that this is actually acting on the joint, and this force is also acting on the joint, because here we have NCCD. So what we're having is that, for example, if I look at joint D, at joint D, what I have is the following. So I have a force acting downwards, which is 2 kilonewtons. Then I also have the one that's acting sidewards is what? NGD. Then the one that's acting in this direction is what? NCD. And here it's what? 56.31 degrees. So, and this is my axis, this is my y positive, and this is my x positive. So what this simply means is I have to find the projection, meaning for me to go to this point, I have to move to this point, then I have to move to that point. And that's why we use what we explained to say it's easy to find our projections. This one, of course, will be NGD sine 56.31 degrees. And of course, this one here will be NGD over cos 56.31 degrees. So I have to label that on my diagram. Remember, this is one whole element or one whole rigid body. So I just label to simplify my forces. So, of course, these are parallel, meaning they're the same. So, meaning we have this portion. I can label my NGD. NGD what? Sine 50 56.31 degrees. Then here, just because I don't have enough space, so it's just the same. Also, at this point, it will be experiencing another force in this other opposite direction, which will be known as what? NGD, but this time it's cos 56.31 degrees. So we'll also do the same at this strength. So if this one is also the same, I'll have to move in this direction, then move in this direction, right? So in this, or move in this direction, then move in this direction. So if I move in this direction, it's quite evident what am I going to get? I'll get NGF of what? Cos 26.67. But we should be careful, it's now moving in. Even this one was moving actually in the negative. I'm supposed to have a negative in front. I'm supposed to have a negative. So those negatives are really important. Then, of course, it will be moving in the other direction, going upwards. This will be what? My NGF, but it will be, of course, a positive with 26.67 degrees. So once I have that, now I can start applying my sum of moments, sum of forces, and yeah, sum of moments and sum of moments. So my equilibrium. So once I do that, so it's one whole diagram. I've labeled that, so others can even choose to say.
So please include the page one.
Put page one too.
Okay, we have page one. So we'll look at page two. So in page two, what we're going to have is, so page two. If I redraw what I have, right? But I can just redraw it quickly. Or you can just use this, it depends. I'm just redrawing it to be a bit more clear. But of course, in your exam sheet or your test sheet, you can even name this to say calculational FBD. So this one is why you're labeling and you're doing all your calculations. Your other free body diagram was just drawn. Then after that free body diagram, you put your other one where you'll be doing all your reference and your calculations here, because it will really help you a lot. So from there, for page two, uh, I'm just drawing it quickly. I have that point, that joint, then I have the following. This one comes up to somewhere there. So I just label quickly. What do I have here? I have my 2 kilonewtons. Then here, what do I have? I have my EY, which is equals to what? 7 kilonewtons. Then here, what do I have? I have two things, right? The first one is my NCD. Then I also found to say in the same direction, what do you have? You also have your negative NGD cos 56.31 degrees. Then in the other direction, we said we have what? Our NGD, at this time it's the sine 56.31 degrees. Then the same thing at this, so this is at E, right? And this is at what? At D. So you also check what you have at F. At F, the same thing. Remember, I have this as X positive. Then I have my Y positives there. These are also my X positives. This is my Y positive. That is common, it's the same. Then for here, I also had the same. So I projected it. And this is what gives me what? My NGF of sine 26.67, right? Then I had it in this direction also. It was minus NGF cos 26.67 degrees. That's what I have. And what's the distance from here to here? And what's the distance from here to here? It is 3. So please, the only other thing you should be careful is units. Because sometimes you find that maybe this was put in centimeters, so when you're calculating, you have to be very careful with your units. Because sometimes it's a unit that can penalize someone. So once you have this is your entire structure. So you begin to apply equilibrium to our right hand side. As simple as that. So once you apply it, you have all your measurements. So on page 3, we just apply equilibrium. So say page 3. So when you apply equilibrium, it's quite easy. We have all the forces, so we just apply equilibrium. So when you apply equilibrium, for example, if we say the sum of all the forces in the x direction equals to 0, if x is positive in this sense, what do we get? We just look what is acting in the x. That's right. Is there anything else? No. So it's just negative NGF, then cos 26.67 degrees. Then there's also what? Negative NGD cos 56.31 degrees. Then don't forget your minus NCD equals to 0. So this becomes more of the equation 1. Here we've got 3 unknowns, so we need more equations. So the sum of forces in the y direction equals to 0. So y is in that direction, positive equals to 0. So I check in my y direction. What do I have in my y direction? I've got this, I've got this, I've got all that. So it gives me what? NGF sine 26.67 degrees. Then what do I have also? Plus NGD. Then I have sine 56.31 degrees. Then what do I have? I have minus 2. Then I have what? Plus 7. And this is equals to 0. So this becomes my equation 2. So it's becoming much easier, right? Because eventually, what am I getting? I'm just getting that NGF sine 26.67 degrees plus NGD sine 56.31 degrees is simply equals to negative 5. So negative 5. So that's my equation 2. Then after that, I say applying the sum of moments about a point and anticlockwise as positive. So what did we say when choosing a point? You choose where you've got the highest number of what? Which point is that? If we look at it, exactly, it's point D because I've got this unknown and I've got these two unknown. So I say the sum of moments about point D. So we said for the sum of moments, what do we do? If we choose this as our pivot, right? So that's our pivot. We said what you do is just draw straight lines that pass through your point of action. So it will be straight like that, right? And then you draw straight like that. So meaning anything that's acting on this point does not have a moment because it does not have a distance. Then from there, look at now your lines of action. Lines of action means your forces. So your other forces, like for example, this one, this is its line of action. So you find that it forms a perpendicular with that. Then this is also your other line of action like that. So you find with that other straight line you drew, it forms it perpendicular like that. So mean you've got a moment there and you've got a moment there. Then you don't have a moment because these ones are just parallel to each other in the sense of they're in the line of action, and where you have your point of action, they share the same axis. So you can't form a moment. So once you have those two, so that's about this point, which is the best to choose, we'll calculate all our possible moments. So here, for our moments, we said we have our small moment guide for our positive sign convention. We said in this direction it's what? Positive. In this direction it's positive. So meaning the other direction is what? Negative. And the other direction is what? Negative. So everything which is going to tend in the anti-clockwise, we consider it as positive, and the clockwise as negative. So we look at this. This force is going up. So meaning the distance times the force going up, what does it do? It goes in that direction. So it goes in which direction? Yeah, positive direction. So meaning we'll get it to be a positive 3 times what? Times 7. Then we'll say, what else do we have? We check. We won't have this other one, right? So we'll have this one also. It's also going in the positive sense, right? So we'll have also a positive. So a positive is translated just as a plus. What's the distance? It's also 3, and the force is negative NGF over cos 26.67 degrees. Like that. And all this is equals to what? Is equals to 0. So you see the advantage of taking this place. It helped us a lot. Why? Because now I find out to say NGF is simply equals to, I take this to the other side, it will simply give me 3, 7, which is 21, okay? Then this divided by 3 by cos 26.67 degrees. So this and this will actually cancel out. And this will give us one of the things we're looking for, which is NGF. What's the value? Calculators. Those with Casio calculators. Okay, any calculators, okay. It just depends on how you use it. This calculator still exists. No, I used to have so many arguments with my colleagues on calculators because the one I use, I think it's the best. But them they'll say this one is better than the one you use. So we'll just be back and forth. I'm like, anyway, we'll see who finishes first. Then they finish before me. So I'm wondering, saying, was it my calculator once? But anyway, any calculator you own, the owner is the one who's the user will actually know how to use it very well. So this will be what? 7.83 kilo Newton. So meaning your member is in what? It's actually in tension. So this will help. So once you find this, this is more of our 3. Hence, 3 in 2. What is going to give us? We just replace. So it will help us find what? NGD. So meaning your NGD will simply be equals to negative 5 minus, we found what? 7.83, then multiplied by what? This will be simply multiplied by our sine 26.67 and divided by our sine 56.31. So if I compute this, what it gives me, because these are just adding up, so it's just the same as my sine 26.6 that multiplied by what? 7.8 that, then plus 5, right? Then I divide it by my sine 56.31. It will give me NGD is equals to negative 10.23 kilonewton, meaning my member is what? In compression. They only asked me to find these two. So the other one is just a list. Huh? Oh, it's actually 10. It's just my handwriting is a bit unique, but in all cases, so that's a 10. So this will be the end of your question. Because in other courses, you also, this is page 3, in other courses, you'll be able to also see how to now, yes, you can now draw, because remember, what's interesting to do is when I come to this, of course, I found the values. Once you find your values, because sometimes you find your using section method on various components, it's the same thing as joint method. What did we say? Once you find, you have to label them. So the first one, for example, it was in what? It was in tension. So meaning on my original diagram, we don't have original diagram here, even on this one. So I'll be able to come to this, right? And label that my member is actually the other way around, right? It's in tension. Yeah, so I'll just do that. And I'll label it from this side, this end, and also just do that. Just to keep it uniform. So I have to label on what's the value intention 7.8, right? 7.83. Then here I also have to label 7.83. So these ones become known. Then I also have to, the other one was in compression, right? So meaning you label, that's my 10.32. So 10.32. And I also label to say my member is actually in compression, which is my 10.223, like that. So you've found for those members. So if you had, for example, another member and you had to cut, like for example, it's evident that I can, if they ask me to find for example, E, for example, let me just write it so you can have that idea on page 5, right? Page 4. Okay, on page 4. So I found those ones. Eventually, I also find what's in this member. So what will happen, for example, if they had to tell me to, no, it wouldn't work because here you've got 1, 2, 3, 4 members. So for example, if I've used section method there, right? So what I can do is I can do the following. So imagine they also said also find in member, let's say that's EF, right? So it's the same thing. So I'll just do that. Then I'll do that for my member. Then I'll also do that because then this was like that, right? Then was there anything here? Okay. Okay. Yeah. So yeah, it was coming like that, right? So I had that, then I had that. So this is what I'm from labeling. So I label this as what? My 7.83, right? Then I labeled this one as what?
10.32.
My 10.32. Then, then, yeah. So here those, this is DF, right? So meaning, for example, here once you have two members, you have to go back to jointer method. But you've already found what this and this is. So once I have this, and of course here there'll be another member, which of course we didn't finish our calculation, is the N, C, D. This will also be none. It will be a certain value that we compute. So you find yourself, for example, if you're looking for this member here, you find yourself having things like in this part here, you have your N, DF, right? Then in this part here, you have your what? Your NF, FE. Then here you also have, of course, here you have your seven, and here you have your what? You have your two, so you have to just label what that is, and you just carry out joint method. When you have two members, here you just have to apply now joint method. So there are questions where they can ask you to say, I'm interested. What happens in this member? So I just pick two members and I pick one. So meaning I pick, for example, this one. So meaning the last one, the first one, instead of using joint method everywhere, you just use joint method for the section one, there are three of them, or section method one, there are three of them why you're interested. Then from there, you just apply small joint method you find in the other member. And of course, when you want to apply joint method for this, you don't apply it here. Just apply it here. It's easier
Yeah.
because you already know the angle that's there. But of course, this one will always remain the same. It's known. Or for example, if they asked you in this member that's here, oh, you've already calculated it, so you find that most of your problems are already solved. So that questions where you might apply section for this, then you apply jointer for this.